Welcome to Study Loop.
Okay, we need to state Hess's law or choose the answer that best represents Hess's law. And we've given some options. Okay, reactions that occur in different sequence will have different enthalpies. Is this Hess's law? No, this is not Hess's law. And how do we know this? Because we know, in fact, that the opposite is true. It does not matter what order you perform reactions in, right? The sequence of your reactions can't have any bearing on the enthalpy. That's like saying, if I mix salt into water in one beaker and then in another beaker, I remove, all the water from the system, that would have a different energy than if I removed water from the system and then mixed salt into water, right? The order of our reactions is completely independent of the enthalpy, right? The only thing that matters for a sequence of reactions in terms of enthalpies is what the sum of the individual parts of the sequence are in terms of those enthalpies, right? In fact, that's all about what Hess's law was. We learned that if we take reaction 1 and then we later do reaction 2 and then reaction 3, that the total enthalpy will be equal to enthalpy 1 plus enthalpy 2 plus enthalpy 3. And that the order of 1, 2, and 3 won't matter. We could have done reaction 2. We could have then done reaction 3 and then reaction 1. And that the total energy for the sequence of reactions would still be delta H1 plus delta H2 plus delta H3, right? So no, this is not the case. Next, we're told the amount of energy to start a reaction will always be greater than the energy released when the reaction ends. This is also simply not true, right? So we're saying that we always have to put more energy in than we will get out when the reaction is over. And this is basically nonsense, right? We know that there are reactions that release heat in a net fashion, right? For example, the combustion of wood, right, doesn't require more energy to get going than we get out, right? It's nonsense, right? The second statement is a nonsense statement. The amount to start is greater than energy released. And that's because, again, there are plenty of reactions where we start at a high energy and end at a low energy, meaning we've done nothing but release energy, right? There are reactions that will take place spontaneously without any energy input, and they don't require more energy to start than you get out in the end, right? We've seen examples of exactly that. They're just purely exothermic. So this is not the answer. That is a nonsense answer. Next, the sum of enthalpy for the parts or steps of a reaction will always be the same for a given reaction sequence, no matter the order the steps occur. And that is Hess's law, right? That's exactly what we said just here. That if we do reaction 1, 2, and 3 in that order, that the total enthalpy will be the sum of enthalpy 1, enthalpy 2, and enthalpy 3. And that if we do the same reaction, but in order reaction 2 first, then reaction 3, then reaction 1, the enthalpy total will still be enthalpy 1 plus enthalpy 2 plus enthalpy 3. Right? The order we perform reactions in is unrelated to the sum total of the enthalpies for the individual steps. There's no relation. So then we can basically say by process of elimination that the final answer is wrong. The measure of the rate of energy transfer in a sequence of reactions will always vary in a given reaction sequence. Again, this contradicts Hess's law, so that can't be true. So the third answer, the sum of enthalpy for the parts and steps is always the same. Regardless of order. Of those part steps.